Hello everyone, welcome to today's session. My name is Zhida. Together with my colleague Hu Jie, we will be discussing the Auto EDA and some of the applicable EDA libraries to you, which will save you tons of time when doing data analysis. Nowadays, EDA is highly important in the business context. It may help you make better data-driven decisions and enables you to better communicate data outcome to your clients. Here is a quick overview for today's agenda. I will first introduce EDA and tell you what it can do for you. And then I will elaborate some of the EDA process, including univariate, bivariate, multivariate analysis, and how to find interactions among attributes, along with some data wrangling and feature engineering, which are actually quite essential. And then my colleague will introduce some Auto EDA libraries and give a comparison among these libraries. So what exactly is EDA? EDA is short for Explorative Data Analysis. It is the approach of data analysis that uses various techniques such as visualization to discover patterns and spot anomalies out of it. Developed by the American mathematician John Tukey in the 1970s, EDA has evolved into the widely used method by data scientists to answer questions, generate and test hypotheses for further analysis, or to prepare the data for modeling. All these usages may demand you to have a very good understanding of your data, or at least have an intuition. So what exactly does EDA do for you? EDA can improve understanding of variables by extracting averages, mean, minimum, and maximum values. It can help discover errors, outliers, and missing values in the data. And most importantly, it identifies patterns by visualizing data in graphs such as box plots, scatter plots, and histogram. Ideally, EDA should bring out insights and realizations from data that cannot be obtained through formal modeling and hypothesis testing. When done properly, EDA can dramatically simplify or advance your data science problem. Let's have a look. To make it easier for you guys to understand, this diagram shows the sequential steps that people could follow when performing EDA. Before EDA, we need to load the dataset in your preferred software. It will be actually Python in this context. You need to then distinguish the attributes of the dataset. By attributes, it means the different variables. For instance, you could have datasets that have features like heights, weights, and ages of school students. These are the attributes that you can start looking into. The next step is to conduct analysis including univariate, bivariate, and multivariate analysis, and then followed by some data wrangling, such as dealing with missing values, duplicates, and outliers. Lastly, and also most time-consuming part, is feature engineering. I will demonstrate these steps in the following. When getting started with EDA, you generally need to perform these three analyses. They are quite self-explanatory. The univariate analysis, it examines only one variable at a time. You can use an example of heights of the school students. You can draw the box plot to see the distribution of it. And the second bivariate analysis looks at two variables and their relationship at a time. For instance, you can look into the relation between age and height of school students, and you actually discover that usually the older they are, the taller they are. And the last one, multivariate analysis, looks at more than two variables and their relationship. So if you are older, but it doesn't necessarily mean that you're taller. You also take a look at the gender. So actually, you need to look into those relationships in order to get some insights. So Having explained these dimensions, we have to then talk about the vertical dimension, the graphical and non-graphical EDA. Non-graphical EDA focuses commonly on measures of central tendency metrics, such as the mean, median, and mode. It also measures spreads, which could be represented by variabilities measure, such as IQR, which is short for interquartile range, and the standard deviation and range. So graphical EDA is about visualizing data. So if you need qualitative analysis, you can adopt this method. For the non-graphical method, it focuses more on the metrics calculation, which will have an output of a lot of quantitative data. Usually in a bigger data set, you will have absolutely multivariables, and it will be quite useful for you to use multivariate graphical method to compare two or more variables graphically, and they are perfect for detecting and analyzing clustering data. Examples could be scatter plots or correlation heat map and pair plots. I will give some financial example in the following. I have just loaded some financial data for you. As you can see here, it is a industry return analysis. We will need to find the interactions among different attributes, in this case different industries, by looking at the covariance between variables. This step is pretty important for risk management and portfolio construction, because when constructing portfolio, you need these insights to achieve a diversification. As on the left side, we have a data frame. Actually, the correlation matrix. It shows us that the correlation of every two variables in the form of a heat map. It enables you to choose industry that is less correlated to diversify your portfolio. The right side is also a graph generated by Detail, an Auto EDA library. As you can see, it generates a similar heat map and requires only one line code to execute it. It has more functionalities to offer. My classmate will represent it later. Once you have successfully defined the relationships between variables, you come to the data cleaning. This is a Python, and you can see that includes handling missing values, detect duplicates, and check outliers. I will demonstrate how to clean the data using Python instructions. Yeah, this is a real estate data set. As you can see, there's a few variables here: the price, the space, bedrooms, and etc. We manually added some noises in this data. As you can see, there's a couple of value missing and some outliers. And first step to clean the data, it will be to check the whole data set using info, or actually can use describe. And now I see that there's some data missing. I'll go by detail using isNow. So now I see clearly there are two prices missing, and other in central heating and in pool. So I'll use different treatments. For prices, I use interpolate to get the interpolated prices here. And then moving on, I use fill NA to replace the non-values using my predefined values. And once these are all filled, I use drop duplicates to clean it further. And now it's more of a tidy. But this is not enough. We will also have to conduct feature engineering. This is to make data more compatible with further processing. For instance, here we have a price, we have space, but it's not really valuable for further analysis. In that case, we'll need to create a price divided by square meter, which is a ratio out of these two columns. It's actually not that hard to conduct. I'll show you in Python. So just type in the data frame, use bracket and quote, and type in the name you wish to name the data set, and then calculate the ratio here. And then it's pretty much done. But actually, there's some outliers I haven't handled, but I'm not going to do it here because you just use a box plots for each variables and you'll see the outliers. This may seem not so hard, but believe me, if you have a bigger data sets, this EDA process will be a nightmare for you. Now we're talking about this, let's move on to the next topic. Why should we automate the EDA process? Well, the biggest reason is that your time is valuable. Automate EDA could easily save you hours and relieve you from the massive coding. And also, manual EDA is not always reliable. Sometimes it requires people to make decisions based purely on their intuitions, which could lead to error. We have reviewed some articles and videos related to Auto EDA, and in case you are a Python user, these Auto EDA libraries are perfect for you. We will demonstrate the most popular Python Auto EDA libraries in the following. They are Detail, Panda Profiling, SweetViz, and AutoViz. And from here, my colleague Hu Jie will take it over.
Hello everyone, I'm happy to take over. My name is Jie Hu. Now I would like to introduce some powerful Auto EDA libraries to you. Since EDA could be a time-consuming task, and it's not easy for us to develop EDA models by ourselves, so using some existing EDA libraries could save us a lot of time. So firstly, I want to show you this detail library. As you can see in the slides, it just requires a few lines of code to get the analyzed report and further information and operations on our dataset. Let me show you this in Jupyter Notebook. So in Jupyter Notebook, firstly we just install detail by using this live code, and then we import pandas and detail, as well as our Excel sheet. And then you can see the dimension of our Excel sheet. Each column represents the time series data of monthly returns of different industries in the US. And then we just use this detail.show to get our analyzed report. It's pretty easy. And then we can click this small button to open this report in a new web page. And in the report, we can do further operations and get more information. For example, firstly, maybe let's have a look on individual variable information. For example, we can see the statistical information on the food variable. We can have the mean value, the maximum value, and the variance. Also, we can get the information for outliers. So let's go back, and then we can also have multivariate analyze report and different kinds of charts. Here we have line charts, bar charts, even 3D scatter plot. Let me show you line chart first. Just select two variables, and then we can get this picture of the relationship between these two variables. And then let me show you this 3D scatter plot. We just choose three variables, and then we can get this 3D scatter plot. And we can even zoom to move it to see the general trend between these three variables. And let's go back. We can also see the information on the interaction between different variables. For example, the covariance, the correlation matrix. Here we can see the correlation coefficient between different variables, and detail even provide this information of correlation between different pairs of variables in different time. We can just click different element to get different time information of correlations. And then let's go back. We can also do the feature engineering. Like here, it has this data frame functions functionality. We can create new columns or do operations on the current columns. For example, we can create new columns of all random numbers, but unfortunately here we can not type the number for variance and mean value. So let's close it. And finally, we can also get the missing analyze on the missing values. But since our dataset is pretty complete, so here we don't have any NaN values. But it would be pretty helpful for other datasets. So this is pretty much about detail library. Secondly, I want to show you this panda profiling library. As you can see, it's also very easy to use, just like detail. It just requires several lines of code. Firstly, we install pandas profiling, and then we import pandas profiling and pandas, as well as our Excel sheet. And then we run these 2 lines of code. We can get this pandas profiling report. Let me show you in Jupyter Notebook. So as you can see, we install pandas profiling by using this line of code, and then we import all the libraries and we run these 2 lines to get our report. The report will be in an HTML page, which located in the same place as this Jupyter Notebook. Here it is. And this is our analyzed report. We can see firstly the overview of the statistical information of our dataset. Then we can see all these univariate analyzed on individual variables. And also we can see the multivariate analyze between 2 variables. We can just choose 2 variables to see the correlation between them. And then we can see this correlation matrix. So the darker the color is, the higher the correlation parameter is. And then we can also have this missing value analyze report. But as I said, since this dataset is pretty complete, so here we don't have any NaN values. And in the end, we can also see the sample of our original dataset. And this is about pandas profiling library. Thirdly, let me show you this SweetWiz package. It's also very simple to use. We just we just install SweetWiz first, and we import pandas and SweetWiz. Also our Excel sheet. And by running these 2 lines of code, we can get this HTML analyzed report. Let me show you in Jupyter Notebook. Here we install SweetWiz first, and we import all the libraries and data. Then we can have this HTML analyzed report. It has all this information about our variables, can see we have this visualization about the distribution. We can also see the associations between variables. This is the correlation matrix. And SweetWiz has a special functionality that others don't have, which is the comparison between different datasets. But the different datasets have to be having the same dimensions in data. So let's move to the next one. Finally, I want to show you this Auto EDA library. It's also pretty easy to install. As you can see, we just install Auto EDA, and from Auto EDA we import this Auto EDA class, and we import our data. Then I just write some default parameters. We run this and we can get the report. Let me show you the HTML analyze report. So after you see, after running this part, we can get all these charts and plots. Firstly, we get the pairwise scattered plots, and then we have the statistical analyze for each individual variables. We have the distribution, the box plot chart, also the probability plot, and we have also the violin plot, and in the end we have this correlation matrix. This is about Auto EDA. In the end, we did a simple comparison among these 4 libraries. In general, Detail has the most functionalities, and it is also the fastest one. SweetWiz also has a lot of functionalities and informations, and it's also very fast. And it has a unique advantage, that is, the user can compare different datasets with it. But comparing with Detail, SweetWiz cannot export code. I mean, the user with Detail can export code and run it in other places. That's a unique advantage. The Panda profiling and Auto EDA, they are a bit slower with big data because I run them with quite a lot of time. Panda profiling has also quite a lot of information, but the user cannot do operations on the original data. With Auto EDA, the user cannot have information on data quality, statistical information, and quantitative information. It only offers the visualization of the data. And this is all about our presentation. If you have further questions, you're welcome to contact us to ask any questions. Thank you very much.